All right, so the purpose of a unit rate, and I don't want to step away too far. I got it on record. All right, so the purpose of a unit rate is to compare things easily. Just like we did with the box of cereal on the Do Now, we can see that although they are different prices with different ounces, it's easy to compare those to see which one is the better buy, or best buy was more than two. See which one is the best buy simply by finding the unit rate. So, say for instance, we want to see who hops the fastest between three students, and Kenzie hopped for 10 seconds, and in those 10 seconds she hopped 10 times. Emma hopped for 15 seconds, and in those 15 seconds she hopped 21 times. Jesse hopped for 20 seconds, and in those 20 seconds he hopped 32 times. Okay, it kind of, if I ask you who hopped the fastest, it's hard right now because they all hop for different what times. Okay, so what we're going to do is convert each one of their speeds or times to unit rates. And the unit rate, of course, this is the independent variable because time has to happen what? So the number of hops would be the dependent variable, or y. And we're going to make sure to find the unit rate, we take our dependent variable and divide it by our, or we can say you take y and divide it by x. So we're going to convert each one into a unit rate to see which one was the fastest and which one was slowest, okay? So we're going to take 10 hops and divide it by 10 seconds. So we know that Kenzie hopped one time every what? Yes, one hop per second. I'm just going to use SEC. All right, Emma hopped 21 times in 15 seconds. So round it out to the nearest 10th. So 1.4 hops per second. And what about Jesse? If Jesse hopped 32 times in 20 seconds, let's do 32 hops divided by 20 seconds. What was it? 1.6. Approximately 1.6 hops per second. So it says using a unit rate, decide which student hopped the fastest. That would be Jesse. The slowest would be Kenzie. All right, so a unit rate is used to compare, to make comparisons. We use it to make comparisons easy. That's why we use it, okay? I can go to the store during my planning and get a little something. I just need to swipe my card and pull something off of it.
I got some money in my wallet.
Want me to PayPal you?
Yeah, you don't $10.
Yeah, let's do 10. Okay. All right, we got it? All right, a proportional relationship is a relationship between two quantities. And what do we say quantities meant? Nobody remembers. What's a quantity? I'm so disappointed. Nobody can tell me.
A quantity?
Yes.
Is it like
A quantity is
That's a unit.
ratio, right?
Two quantities means something between two numbers, guys.
Well, two quantities is just two amounts, right?
Yes, yes. All right, so a proportional relationship is a relationship between two numbers in which the unit rate of one is equivalent to the other. Oh, and when I say unit rate, to find a unit rate, what do we have to do with the two measurements? Divide. So when I say unit rate, I'm basically talking about their ratios, okay? Because you got to have one thing and another, okay? The ratios have to be equivalent to each other. So, but I want to put unit rate because the unit rate is the ratio. That means it's that y or that dependent divided by the independent. Make sure you put ratio, okay? All right, so that common ratio of course, I just told you is your unit rate. And it's also called something, this is from 7th grade. Remember, I'm piggybacking off of a 7th grade skill to get you to your 8th grade standard, okay? It's also called a constant of proportionality. All right, 2 other names for this common ratio you're going to hear are rate of change and slope. So this is 8th grade. That's 8th grade. In 7th grade, we normally refer to it as a unit rate or a constant of proportionality. But in 8th grade, you learn that it's the same as rate of change and slope, guys, okay? Okay. And we'll do slope on Monday. It says we'll do slope later. That will be on Monday when you return, okay? So there are actually 4 names. 3 other names for unit rate? What's one of them? Constant of, rate of, and what's the third one? Everybody got it? They all mean the same thing. All right, so we're going to just see if the table below represents a proportional relationship between its time and number of words. Oh. All right, so it says your unit rates have to be what? Equivalent, okay? We get a unit rate by taking the dependent and dividing it by the what? Independent. That makes our ratio. All right, so what we want to do, it says determine if they are proportional. If they're proportional, we're going to name or write the unit rate. Everybody with me? Okay, so to see if they're proportional, my ratios have to be what? Which just means they must be equal. And that ratio is just what is when you divide your dependent by which means your unit rates must be equal. Because those ratios make the unit rate, okay? All right, so heads up, guys. Now, if those unit rates are not equal, we say it's not proportional, right? Because we're not getting the same thing all the time. All right, so before I even start, I know to find a unit rate, I'm going to take my my dependent variable and divide it by my, which is taking y and dividing it by what? Okay, everybody with me? All right, so I'm talking about time and number of words in this table. Which one of those would happen first? Time. So time is going to be my independent or what variable? And the number of words is going to be my dependent or what variable? So for each one of these coordinates, guys, because you can plot them on a graph. You got an x of 1 and a y of 45. You can plot them. All right, so for each one of these, I have to see what the unit rate is. So I'll just find the unit rate by taking my y coordinate and dividing it by my x coordinate. What's the first y in the table? So that's 45 words, and it's actually per 1 minute. That's already a unit rate. But I just need to check it all the way through the table to make sure that they stay constant or equivalent, okay? What is the second y coordinate? So this person can type 90 words in 2 minutes. Divide that and see if you still get 45. 90 divided by 2 is 45. So right now, this person's speed is remaining the same. So we say it's remaining constant. Tyler, you can step out. You can step out. I'm not even going to waste my time teaching somebody with their eyes closed because you're not learning anything anyway. I love you to death, Tyler, but you know you're wrong, okay? All right. Now, if they type 135 words in 3 minutes, is their speed remaining constant? Let's see. Yes? So they're still typing 45 words per what? Y'all must be playing a game over there. I guess you're gonna play one in his room today. All right. So if this person types 180 words in 4 minutes, is their speed still remaining constant?
Yes.
What you doing, Michaela? Okay, I don't care about no I read it right now. I'm teaching. You know, I don't want to brag on you to Mrs. Lee, and you in here doing I read it while I'm teaching. Still 45 words per minute. Okay, now, Michaela, I'm going to see if you were paying attention to me too. What do I do to see if the speed is still remaining constant? Thank you. Are they still at the same speed, guys?
Yes.
Still 45 words per, yeah. So since their speed remained constant, we say it's what? Proportional. That's all that means. Is their unit rate in this particular case, it's words per minute, which is speed, the typing speed. So their typing speed remains constant, so we say it's proportional. I'm going to put since the typing speed remains constant, it is a proportional relationship. Everybody got it? And when I say it's, I'm talking about the relationship between the number of words and the number of words and the number of what?
Minutes.
Minutes. Yes. Yes, very good. All right, everybody got it? All right, so we're going to fill this table in, and then we're going to see if it's proportional, okay? All right, so the Vista Marina rents boats for $25 an hour. So we're going to say, let's say Micah decides that he's going to go out to the Vista Marina. He's going to rent this boat. He knows he has to pay $25 an hour, but he doesn't care. You know, it's a nice, pretty weekend. He wants to take his girlfriend out. I'm just going to go out there and ride around on the lake, okay? All right. All right, it says, in addition to the rental fee, there's a $12 charge for fuel, which means you got to put some gas in it. What are they going to charge you to put your gas in? They'll fill it up for you. They're charging you $12, but they still want you to pay what? $25 an hour, okay? So, Mike, if, you stay out there for an hour, you only got to pay $25 plus the gas, okay? You stay out there for 2 hours, you got to pay what? $50 plus the gas, okay? Is that too much? To rent those pontoon boats on the lake, because I wanted to rent one this past summer, and it was like, I don't know, like $400 for so many hours.
For how long?
I can't remember the number of hours, but it's okay, because you know what? When you rent a boat, you probably go out to little islands with a lot of people, you barbecue, and y'all kind of split the payment up.
After so many hours, you're gonna lose gas. You gotta buy more.
Well, you fill it up, so it's pretty good on gas. But like, y'all, let's go. Let's. I got distracted. All right, so it says, is the number of hours, so 1 unit is hours, that you rent the boat, is it proportional to the cost? In other words, is it going to remain the same every hour, okay? Every hour that goes by. Is that cost going to remain constant every what? Hour. Does that make sense to you?
Yes, ma'am.
All right, so let's just calculate how much Michael will pay for 1 hour. What is he paying for 1 hour?
12.
37. Y'all know where the 37 is coming from?
Yes.
Yeah, he has to pay the $25 for renting the first hour,
I'm sorry.
plus the $12 in gas, which means he has to pay, yeah, a total of $37 if it's going to keep it out there for an hour. Okay. All right. What about if he rents it for 2 hours? What is he going to pay, Kaden? $67, because now he has to pay $50. That's going to cover the $25 for the first and the $25 for the second hour. That's $50 plus he still has to pay the gas fee. So he's paying what now? $62. Okay. What did you say, Kaden? Did you say 62? Ooh, where's 67 come from? I'm just curious. You don't know? Okay. What if he keeps it out there for 3 hours, Hunter? Because he has to pay
75 plus
For-
the gas.
yes, plus the gas bill. 75, 25 for the first hour, 25 for the second, 25 for the third, plus the gas puts us at $87. I just need to know, is his cost gonna be proportional? Is it gonna remain constant for every hour, guys? I heard a yes and I heard a no. Okay, so let's check. Which one of these is independent? Jason?
Rental time.
Yes, rental time. That's hours, guys. And then the cost is, all right, so let's see if his cost is going to remain constant every hour. If so, it's proportional. If it doesn't, it's not proportional, guys. So let's take 37 and divide it by 1 hour. Basically, he's paying $37 an hour. That's what it starts off being. All right, and then next, let's take his $62 and divide it by, what is he paying per hour there? This one was 37 per hour,
31.
and this is 31 per. That's definitely not proportional. His cost is not remaining the same each what? Yeah, each hour. So I'm not even going to check the third one, guys. That's a waste of pencil lead and time. So let's put that it's not proportional. His cost per hour changed. We get it? Why do you think the cost per hour changed though? Like what did we throw in there that made it different? The gas money, yeah. All right, let's take a look at C, and we're going to see which one of these plants, plant A or plant B, has growth that remains constant every week, I believe. Yes, it's every week. Now, if your plant growth remains constant, you say it's proportional. If the plant growth doesn't remain constant, it's not proportional. All right, so it says plant A, and I know we got plant A and plant B. And we're trying to see which situation represents a proportional relationship between the plant's height, which is the plant's growth, and the number of weeks. Is it growing? We're going to figure out which one is growing the same amount every what? Week. Oh, not until we figure out which plant is growing the same every week. Okay. All right, so what did plant A do the first week? Yeah, how tall is it? What's the growth?
18.
Well, it's not the growth, but that's the height. Okay, so it's 18 inches in 1 week. So that's 18. And I know the week has to be my, because it's time. So the inches have to be my dependent. So just make sure you take your dependent or your y and divide it by your x, okay? All right, so that's 18 inches divided by 1 week. So basically that plant is growing 18 inches per week. What about in 36 inches? That was after. So did it grow another 18 inches? Yes, it grew another 18 inches in that week. Okay, so far it's what? The plant growth is constant. What's another word besides the plant growth is constant? That it's proportional, okay? It's not changing. All right, and then it grew 56 inches. It was 56 inches after 3 weeks. Let's see if it grew another 18 inches, guys. Did it?
It grew 18.66.
It grew 18 and 2/3, basically, okay? Because I'm going to approximate this to 18.7 inches. The growth did not remain the what? So that one is definitely not. Okay, so I know you all know that plant B is. I'm going to go ahead and list that it is. But I'm also going to verify by doing the what? Doing the work finding the growth rates per week.
This plant B might also. be-
Okay, plant B grew 18 inches after 1 week, so that's the same as plant A. I'm not going to rewrite it when it's already right there. Okay, guys? Okay. All right, and then 36 inches after 2, well, that was the same as plant A. So right now, it's still growing 18 inches per what? The only one I need to check is the third one. So after 3 weeks, it was 54 inches tall. That's different. So let's take 54 inches and divide it by how many weeks? Did it grow 18 inches that week?
Yes.
Yeah. So that just verifies that my growth stayed what? Proportional. And another word for that? Constant. Okay. So every week it grew 18 inches. So that's why we can say that it had a proportional growth rate or a constant growth rate. Everybody understand what proportional means now?
Yes.
It's pretty simple, isn't it? All right. That's it for today. Y'all have free time for 16 minutes.